Hey Sadie and Jose. Okay, this lesson today for 8.3 is something that we've never ever talked about before, okay? It's basically like it's like computer language, okay? One, we're gonna talk about the history of computers, which I'm not gonna skip over that part because it's interesting and it is something that you need to know. We take for granted where computers come from now. Computers are everywhere. We don't think about the past computers or anything like that. But if you remember the movie Hidden Figures, remember that at that point, computers were not normal. Computers were not taken for granted, and they were huge, and no one knew how to work them, et cetera, and that's where we came from, you know. So now we do know how they work, but honestly, we don't know underneath what is going on. Okay, we think that before we start to read, we only use one number system, right? We use 0 through 9. That is our number system. All the numbers that we use go through, are created from 0 to 9. This number system is called base 10. Why? Because we have 10 digits to make all of our numbers in our number system. 0 to 9, okay, 10 digits. However, computers use base 2. So what do you think that means? That means all their numbers are formed by 2 digits. And you're like, well, how in the world is that possible? And I was like, I don't really know either. So I had to YouTube it, and then I figured it out, and it's super interesting. Doesn't mean that I'm perfect at it, so we're gonna have to kind of cheat on a few things. But it is interesting. It's like it's a code. Okay, it's a whole different language. So we'll get into that because that's part of your homework today. And it's good to know that computers are based on base 2, not like our number system that's based on base 10. Okay, so let's read. It says, enjoying the computer. It's gonna be funny because you're gonna see how old this book is, but that's okay. A computer is a device used to process information by using stored instructions. Those are called your program, okay? So somebody has to go in there and put that program into the computer. Someone has to go in there and put the instructions into the computer so that when you sell that computer is gonna follow those instructions whether or not the creator and inventor of that computer is there or not, right? So what is that person called? The human being is called the programmer. Once computers were affordable only by large businesses, but improved technology and lowered production costs have made electronic computers readily available to even the smallest businesses. In fact, your family probably owns a home computer called a microcomputer. Okay, that's how old this book is, that it's not even common yet, when this book was made, that a lot of people have their own computer. No doubt you have spent many hours playing electronic games and composing themes on your computer. Perhaps you head to the computer before greeting the cat when you get home. Computers are definitely a part of leisure and work time of the modern student. Well, some of you guys don't have, maybe you don't have a computer at home. You do have a phone, which is also a computer at this point. Your grandparents may be baffled, that means surprised, by the computer age. That is understandable since less than 60 years ago, calculating machines were mechanical rather than electronic and were slow. In 1944, the Mark I computer was developed at Harvard University by IBM and the United States War Department to aid in computations involving high-volume military supply operations in World War II. Mark I was a mechanical automatic calculator that filled a large room and produced an almost deafening noise. 2 years after Mark I, the first electronic computer called ENIAC, which is an electronic number integrator and calculator, was developed. Using electronic vacuum tubes rather than mechanical counters, ENIAC was much faster than Mark I, but its power usage and failure rates were high. In the early years, only a few experts had any contact with computers. Since ENIAC, tremendous advances have resulted in smaller, faster, and more reliable systems. Today, look at that word right there, I hope you're following along, minute, not minute, minute, that means very, very tiny. Semiconductor chips comprise the central processing unit of the computer. That's called your CPU. Mathematical operations are measured in nanoseconds. Okay, so that's 10 to the negative 9 of a second. So today's computers are fast, powerful, easy to operate, and relatively inexpensive. They're expensive. Not as expensive as these were, though, in history. The need to measure and count and do so more and more rapidly as society increases in complexity are the reasons behind the development of computers. To perform these two functions, there are two basic kinds of computers. Okay, so look at this. There's analog and digital. What is analog? Analog computers measure. These are not your common computers. Digital are your common computers. The word analog comes from analogy, which means a resemblance between things otherwise unlike. Think about a clock. A clock is considered an analog clock, watch, or your watch if it has hands on it. It's analog because there's an analogy between the position of the hands and the time of day, okay? You see the position of the hands and you know what time of day it is, but really, otherwise speaking, little hands on the clock shouldn't have anything to do with the time of day. They're two things that come together to represent each other that usually wouldn't make any sense to represent each other. Analog computers are found in many new automobiles where they maintain speed, keep the car level in hard braking, and vary other performance characteristics in response to changing needs. Other examples of uses for analog computers are the automatic pilot in airplanes, okay, because you know if you're in an airplane, the pilot is not flying the entire time. They put it on an automated system and then watch things so that that they're there in case a problem happens, that they're there to intervene if they're going through hard storms and different stuff like that, but a lot of it is automated now. Flight simulators for airplane or space vehicle training and process control in steel mills and other factories. Digital computers, that's what we're going to talk about, count. They solve problems by counting in contrast to the measuring done by analog computers. A digital clock, for example, jumps from one digit to the next. So an analog clock, you watch it go second, 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 and then it turns to minute, 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 minute. That turns the hour, 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 right? But in digital, you just see it count up, right? So it jumps from one digit to the next rather than moving smoothly from one to another in an analog clock. Most digital computers are made for general purpose use and can be programmed to do many different tasks rather than only specialized tasks. The digital computer is generally the type referred to by the word computer. Okay, so you don't say, I have a digital computer, because the computer you have is digital, okay? Rather than counting by using a number system with 10 digits, like I said, the digital computer counts by using only 2 digits, which is called your bit, because it's binary digit. Bit. Okay, binary means 2. Each binary digit is known as a bit. Such a number system known as a binary, meaning 2, is ideally suited to a computer because electronic circuit components can be in only 1 or 2 states at any time, either 1 for on or 0 for off. To count in the binary system using only the digits 1 and 0, study the counting chart to see how to count in base 2. Okay, I'm going to show you how I learned how to count in base 2. Then you have to try to get the rest of them for your homework, because this chart right here only gives you 1 to 20, and your homework wants you to count from 1 to 28 in base 2 in binary numbers, okay? I'm going to show you the logic behind it, and then I'm going to see if you can do it, okay? I'm not going to count all the way up to 20 because I think that you're going to catch on to the pattern, okay? I think this video is going to go 2 parts, so bear with us. Okay, look, I'm going to write it down over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to go to 10 and see if that helps you, okay? Basically, what the logic is, you guys, is this. Like I said, base 10, you have 10 digits to help you form numbers, okay? So you just keep going up by 1, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You just keep adding 1, okay? Now, when you get to, you need to do 10, you need to form the number 10, what do you do? Because now, all of a sudden, you have no more single digits to represent 10. So, you start back at the beginning, okay? So, when you start back at the beginning, you start with 1 now because 0 is not going to give you any value, right? So, when you need to go now to the next number, you need to go back up to 1 and use your 0, and that's your next number using 2 digits now. Now you need another 2-digit number. You're going to add 1 over here again to 11. Well, it's the same thing over here. If you need to, your choices are 0 and 1, okay? So obviously, how do you represent 1 in base 2? 1. But how are you going to represent 2? Because you only have a 0 and a 1. So you're going to keep your 1 and put a 0 on it. So now, so 2 in base 2 is 10. Well, how are you going to go up 1 more? You're going to add 1 to 10. Okay? So look, you start with 1. You can't add anything to 1 because there's no other digit that's going to be a single digit. Okay? So you had to add a 0. So now you have 10. Now you can add 1 to 10, and that's going to be 11. So that's your 3. But now what are you going to add to 11? You can't add another 1 right there. So now you have to go up to the next highest number using 1s and 0s. So you're going to do 100. Okay, now go up to the next highest number using only 1s and 0s. So 101. Right? Then go up to the next highest number using only 1s and 0s. The next one's going to be 110. Then the next one's going to be 111. Okay, but now we're at 111. You can't go up to 112, 100, nada más. So now you have to go up to the next place value. So 8 is going to be 1,000. Okay, so you keep filling. You fill in your tens place until you can't fill anymore. Then you fill in your hundreds until you can't fill anymore. So again, let's count it to get the pattern, right? Because I know that it's confusing. Start out with 1. You can't do anything in the ones place now, so you have to go into the tens. So you make a 10. Next number up from a 10 using 1s and 0s is 11. Nice. But other than that, there's nothing else in the tens place you can do. So now you have to move into the hundreds place. You get 100. Let's fill up the hundreds place. You have 100, 101. Next number up using only 1s and 0s is 110. Next number up is only using 1s and 0s is 111. Next number up using 1s and 0s is nothing in hundreds place. So you move into thousands. So here you go. Now we have 1,001, right? Next one that we can do is 1,010. I'll go up to 15. After 1,010, we have 1,011. After 1,011, we have 1,100. After 1,100, we have 1,101. After 1,101, we have 1,011. But now we filled up our thousands places, so now we need to go into 10,000. Ooh, no, I forgot one. Oh, sorry. 1,101, 1,110, then 1,111, and then 16 becomes 10,000. Okay? You just keep filling up. It's all right there on page 235, though, so that you can try to guess your next number. If you look at number 20, I'll do 21 with you, okay? Because you're going to need to go up to 28 in your homework. It's 10,100. So what's the next number up from 10,100 using only 1s and 0s? 10,101. So that's going to be your number 21, 10,101. Okay? So let's see how it goes. It'll be fun. Okay, look at page 236. So if you know how to convert base 10 numbers into base 2 numbers, that's what I just taught you, converting base 10 numbers into base 2 numbers, now you need to convert base 2 numbers into base 10 numbers, okay? And I'm going to teach you how to do that using the model problem. Let's just skip this explanation on here. It was a little weird. So let's look at model problem number 1. You have 1001. When it has this there, that means that it's in base 2, but you need to get it to base 10. So how do you do it? You're going to write this in expanded form. Okay, write this in expanded form. How do we do that? We go like this. Take this digit 1 times something plus 0 times something plus 0 times something plus 1 times something. Okay, what's the something? Okay, we have 1, 0, 0, 1, right? That's what we have to do to expand it. Then we started over here. It's base 2, so we have 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, okay? That's how you do it. You put your digits, then you put base 2, starting with the exponent 0, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, count up until you're done with your digits, okay? So this is gonna be 1 times 2 to the 3 is 8, plus 0 plus 0 plus 1 times 2 to the 1 is 1. 8 plus 1 is 9, base 10. So this base 2 equals this base 10. Okay, let's do another one. There's a long one here. We're so close to making this video one part. Sorry about that, but here we go. 1, 1, 0, 0, 1, 1, 0, base 2. So we're going to go 1 times plus 1 times. And if you're thinking to yourself, well, like, why do I have to put these zeros here? Because you don't want to lose your place value. If you just skip the zeros because you know they're not going to have any value, now you mess up what exponent you need to be working with. Okay, so let's just make sure we have it right. 1, 1, 0, 0, 1, 1, 0. Okay, so I'm going to start here. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6. Okay? Whew. So here we go. 1 times 2 to the 6 is 64. Plus 1 times 2 to the 5th is 32. Plus 0 plus 0 plus 1 times 2 to the 2 is 4. Plus 1 times 2 to the 1 is 2 plus 0. So now we have 64 plus 32 is 96. Plus 4 is 100. Plus 2 is 102 base 10. Okay, and that is your lesson for today. So I told you how to do the first part, 1 through 28. Number 29, your answer is 14, just so you know if you're getting those right. 37 through 40 is literally just putting it into your calculator like normal, so don't worry about any of that being weird. And then the rest are word problems. So if you have any questions, just let me know. Bye, guys.